Hello students, today we're going to look at section 5-3, which is interpreting rate of change and slope. Now you'll probably remember from last year, and a lot of this is going to be reviewed so it's going to go pretty quickly. You remember from last year that slope meant a lot of things. One, it meant rise over run, which is one way we could find slope. And you used a formula to find slope last year, which was y2 minus y1 over x2 minus x1. And so we're going to look at both of those pretty quickly and just remind ourselves what slope is, but then we need to really focus on interpreting the slope and what slope or rate of change means. So I have two lines drawn here, and I apologize that they're not really clear, but that you don't need to draw them because you remember this from last year. So we're going to start with the blue line, and I have 3 points on the blue line, -6, 1, -3, 3, and 3, 7. And one way we can find slope is rise over run. And so what I want to do, and I don't know how you were taught this, but what I always encourage students to do is start with the lowest point on the line. And that way we can rise and run. If you start with the high point, you kind of have to fall and run, and that just kind of sometimes confuses us. So if we can start with the lowest point, so I'm going to start with this point right here, -6, 1, and I'm going to see what do I have to do to get to this -3, 3. So I'm going to draw loops so that you can see a little better. So I have to rise 1, 2. So my first rise is 2, and I have to run 1, 2, 3. So I rose, which makes it positive. I ran to the right, which makes it positive. So the slope of this blue line so far, it looks like, is 2 over 3. But you know, I've got another point over here. Let's just see if it works with that as well. So from this point, I'm going to rise 1, 2, 3, 4. So I have 4 over, my run is 1, 2, 3, 4, 5, 6. 4 over 6. Now what does 4 over 6 simplify to? You're exactly right, it simplifies to 2/3. So the slope of the blue line, and I should put blue since I'm writing in purple because it's darker, the slope of the blue line then is 2/3, and it's positive 2/3 because it's rising from left to right. So let's look at the slope of the green line. And the green line is kind of light, and I wrote the points in red so it'd be darker, so we're just all colorful today. So my point here is 3, 1, 1, 5, and -1, 9. So again, I want to start with my lowest point, and my lowest point is 3, 1, and I'm going to go, what does it take to get me to 1, 5? So I'm going to use my loops in our eyes. 1, 2, 3, 4. So I rose 4, but then I ran to the left 2, and since I'm going to the left, it's negative. So we have 4 over -2. Now what does that simplify to? 4 divided by -2 is -2, so my slope is -2. If you want to, and I would encourage it for later, you can write -2 over 1. Both of those work. But let's see if it's the same from 1, 5 to -1, 9. So I would rise 1, 2, 3, 4, and then over 2, exactly the same. So it would be 4 over -2. So the slope of the green line is -2 over 1. So now that we found rise over run, let's look at the slope formula, and let's use the slope formula to find the slope between 2 points. Because I'm not always going to be given a graph, but I'm actually still going to use the same points that we just used and show you how I would find slope from those 2 points. So you'll remember that the formula for slope is y2 minus y1 over x2 minus x1. y2 and x2 are one ordered pair, y1 and x1 are another ordered pair. Doesn't matter which one's which, we just have to have 2 ordered pairs. So I'm going to start with the blue line, and I'll write blue over here. And I need 2 points on the blue line. I have -6, 1, and I'm going to use 3, 7. -6, 1, and 3, 7. So we'll write over here -6, 1, and 3, 7. Okay? So now I need to plug those in. I'm going to say that this is y1 and this is y2. I can pick, it's my life, I can choose. So I'm going to choose which one's y1, which one's y2. So we're going to start with, oh, sorry, that's not y1 and y2, that's point number 1 and point number 2. Okay? So m equals, y2 is going to be 7 and y1 is 1. So we've got 7 minus 1. And x2 is going to be 3, and we've got minus negative 6. Okay? So now I have to keep going. 7 minus 1 is 6, and 3 minus negative 6 is positive 9, and 6 over 9 simplifies to 2/3, so the slope of that blue line is 2/3, which is exactly what we got when we chose rise over run. So I can choose any 2 points, plug them in, and there we go. So now let's try it for the green line. I feel like I'm calling subways, green line, blue line, red line. Give me 2 points on the green line. We're going to use 3, 1 and negative 1, 9. 3, 1, negative 1, 9. And this is going to be point 1, and that's going to be point 2. So once again, I'm going to plug them into my slope formula. y2 is going to be 9 minus y1, which is 1, over x2, which is negative 1, minus 3. Okay? So 9 minus 1 is 8, and negative 1 minus 3 is negative 4. And I know that 8 divided by negative 4 is negative 2. Or, if you wanted to, you could write it as negative 2 over 1, because we need the rise over run part. Negative 2 or negative 2 over 1, both of those are fine for your slope. So once again, we chose rise over run, or we could choose, using the slope formula, y2 minus y1 over x2 minus x1. Now, you're going to have the slope formula on a formula chart, but it would be really, really good if you memorize that one, because it's just easier to memorize than have to go back and look for it every time. The last little section that we need to talk about is actually interpreting the slope or the rate of change. So if my slope is 2 over 3, what does that mean? Well, let's look at it. If we're looking here at our graph and we look at these points on the blue line here, what this means is that for every time that the x increases by 3, the y increases by 2. So as x increases by 3, y increases by 2. Now, typically, you would have a real-world situation that you would be graphing on these lines, and x would be identified as time, perhaps, and y would be identified as distance. So it could be, so every time you traveled 3 minutes, you went 2 miles, or something to that effect. But that's how we interpret the slope. Now, let's look at a slope that's negative. So this one is the green line. You know, it's a negative slope because it goes down from left to right. We have a green line. And notice how I wrote the slope this time. I just have the negative on the outside. It's not attached to either 2 or 1. I have negative 2 over 1. So the 2 could be negative and the 1 could be positive, or the 1 could be negative and the 2 could be positive. We can do it either way. So in this case, what it's saying is, and I can interpret, I always start with the x, as x decreases by 1, y increases by 2. Does that make sense? As the x increases, sorry, as x decreases. As x decreases, as I go down, the y increases by 2. So as I go down, the y increases by 2. I said that wrong. As I go left, y increases by 2. As the x decreases, which means I go left, y increases by 2. Now let's look at it the other way. As x increases by 1, y decreases by 2. So let's look at that. If I go right 1, which would be an increase in the x, then I'm going to go down 2, which is a decrease in the y of 2. So as x increases, which is moving to the right, y decreases by 2. As x increases by 1, y decreases by 2. So what you're going to do when you interpret the slope is you always look at the slope and you say, when x does what, then y does what, based on what your slope is. When x increases by 3, y increases by 2. When x decreases by 1, y increases by 2. When x increases by 1, y decreases by 2. And again, you're going to have these in world connotations of businesses or garage sales or concession stands or whatever, and it's going to help you understand what this actually means when we talk about slope and rate of change in those problems. Now here are your 2 practice problems for tonight. First one, find the slope of the line that passes through 4, 3 and 2, 5. The second one, find the slope of a line that has an x-intercept of 7 and a y-intercept of 3. Hint, what is the ordered pair for the x-intercept? What is the ordered pair for the y-intercept? Then use your slope formula. Make sure you do these in your composition book, take a picture of them, and submit them using the turn-in button in Edmodo. Make sure you get that done before class starts.